Hello and welcome to Selection with Sathi. Today we study classic coroutines from Fluent Python chapter 19. These are generators used as coroutines, where yield is not just for producing values, but also for receiving them. We will cover send, the four coroutine states, priming, throw and close, and how yield from captures return values. In a classic coroutine, yield appears as an expression on the right side of an assignment. Value equals yield result. This line does two things. First, it yields result out to the caller. Then, when the caller calls coro.send with data, the coroutine resumes and data is assigned to value. This makes yield a two-way communication channel. It sends data out and receives data in. A coroutine goes through four states during its lifetime. Gen_created is the initial state. The coroutine has been created but not started yet. Gen_running means it is currently executing. You rarely observe this state. Gen_suspended means it is paused at a yield, waiting for next or send. Gen_closed means it has finished, either by return, reaching the end, or being closed. You can check the state using inspect.getGeneratorState. Before you can send values to a coroutine, you must prime it. A freshly created coroutine is in the Gen_created state. Its code has not advanced to the first yield yet. Call next of coro or coro.send of none to advance to the first yield. Only after this priming step can you send actual data values. A common pattern is to write a coroutine decorator that autoprimes on creation. The throw and close methods give you control over coroutine termination. Coro.throw raises an exception at the point where the coroutine is suspended. If the coroutine has a try except that handles it, execution continues normally. Coro.close raises GeneratorExit at the yield point. The coroutine should not yield after receiving GeneratorExit. It should clean up and return. Close is called automatically when the coroutine is garbage collected. When a coroutine uses return with a value, it raises StopIteration. The return value is stored in the StopIteration exceptions value attribute. Direct callers must catch StopIteration and read .value to get the result. But yield from handles this transparently. When a delegating generator uses yield from on a subcoroutine, the subcoroutine's return value automatically becomes the result of the yield from expression.
Let's build a running average coroutine. The function initializes total, count, and average to none. In an infinite while loop, value equals yield average. It yields the current average and waits to receive the next number. We prime it with next, then send 10, average becomes 10. Send 30, average becomes 20. Send 5, average becomes 15. The coroutine maintains its state between sends. Exception handling in coroutines uses try except around the yield. Our resilient coroutine wraps value equals yield inside a try block. The except clause catches value error and prints a message. When we call coro.throw with value error, the exception is raised at the yield. The coroutine handles it, prints the message, and continues to the next yield. If we threw an unhandled exception, the coroutine would terminate. Yield from delegation connects a caller to a subcoroutine transparently. Our averager subcoroutine accepts numbers via send and returns the average when it gets none. The grouper coroutine uses result equals yield from averager. Every send from the caller passes through to averager. When averager returns, its return value becomes the result of yield from. We send 10, 20, then none. The grouper prints average 15.0. The taxi fleet simulation shows coroutines as lightweight concurrent tasks. Each taxi is a coroutine that yields events, pickup, drop-off, going home. A dequeue holds all active taxi coroutines. The event loop pops a coroutine, calls next to get the next event, and if the coroutine is not exhausted, pushes it back to the dequeue. This round-robin scheduling interleaves the taxis, a simple event loop built entirely from coroutines.
Key takeaways on classic coroutines. Always prime a coroutine with next or send of none before sending real values. Use yield from to delegate to subcoroutines. It captures the return value automatically. Wrap yield in try except to handle exceptions thrown in via throw. Classic coroutines are the foundation for async and await. Understanding them will deepen your knowledge of modern async Python. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.